All right, Chapter 16, Four-Wheel Drive, Diagnostics, and Service. So in the last chapter, we discussed various all-wheel drive and four-wheel drive systems that are on the market. Manufacturers come up with all kinds of different arrangements for parts and pieces in order to achieve all-wheel drive and four-wheel drive. We talked about part-time four-wheel drive. We talked about full-time four-wheel drive. We talked about all-wheel drive. Almost dropped my book. All-wheel drive and the various components that are found between all these systems. Today, we want to start talking about diagnostics. And first things first, in order to diagnose a four-wheel drive system, you need to get good information from your customer as to what exactly is going on. From my experience, most customers are going to bring a vehicle to you with some sort of noise issue or a lack of four-wheel drive engagement. And so what they might say is there's a growling sound. And they might not have any idea exactly where that growling sound is coming from. Or they might complain that the vehicle is slipping on the road and it's not acting like it's in four-wheel drive. And so there could be a noise, there cannot be a noise. It just depends. And so a thorough test drive and a good review with the customer over what the exact problem is going to be important here. So the first thing the chapter talks about is measuring tires. Now, this is true with your viscous clutch style four-wheel drive systems primarily. Your tire size has to match. And so customers that are owners of all-wheel drive vehicles, they need to be made aware when they have like a tire blowout, for example, that you can't mix match tread depth on all-wheel drive vehicles. You can cause limited slip burnup. You can cause viscous clutch burnup and binding issues that can actually strip out splines and components like that in all-wheel drive vehicles. In your part-time four-wheel drive, this is not important. Okay, and so I've had customers in the past with a four-wheel drive pickup truck that need tires replaced, and they come in requesting all four, when in reality they only need to buy maybe two because two of them are in pretty good shape still. Two of them are, past 50%, down to maybe 20% worn out, and they think they need to buy four because they have a four-wheel drive and they don't want to change the tread depth. They want to keep it matched. Well, on a part-time four-wheel drive, tread depth difference doesn't matter. You always want to match the exact tire size, right? So like a 245, 75, 16. You don't want to start mixing up, 245 and a 235 and 85 and a 75. That just goes without saying. But tread depth is very important on your all-time all-wheel drive vehicles. There are lots of cases out there where manufacturers are putting out publications and voiding warranties even because customers have maybe had a blowout at 50,000 miles. They picked up something on the highway and popped a tire, and they replaced only one. So they refused to replace all four. I've had customers that have gotten very, very concerned with the cost when you tell them they need to replace all four tires when they only have one tire that actually has a sidewall rip in it. It can be very costly. It's become such an issue that tire manufacturers, like tire machine companies, like Hunter, for example, you can research these specialty machines on the market, but what they'll actually do is they'll take a brand new tire and they'll mount it in a special shaving machine. And so if you have four tires that are maybe at 75% tread life, one of them gets a rip in the sidewall, so it has to be junked. It can't be patched. What you can do is take a brand new tire and grind the tread down to where it matches the other three. And it's actually, I don't know if I would personally do it, but for somebody that is on a budget, it definitely will be the cheaper option. Now, I wouldn't do that if you had all your tires were down to, below half life. It probably would not be a good suggestion, but maybe somebody just replaced tires in the last year and they've got quite a bit of tread life left on the other tires. In a case like that, if that tire's, maybe the tire is even warranted, right? Maybe there's some sort of road hazard warranty on that tire. And so it's only going to cover that one tire. It's not going to cover all four. So the customer might not even be paying for the bill in this case. They may just get a tire that matches tread depth in the end, and down the road they go. So always measure the tread depth anytime you're trying to diagnose four-wheel drive issues. This could be a noise issue, a binding issue, or it could be after there's been a hard part that's actually broke. You always want to try to figure out what the root cause of the problem is. And so if you've got a customer that maybe picks up, buys used tires, right? And the tire guy doesn't really care. He's making a sale, so he's selling them 4 tires that don't match in tread depth. And now the customer comes into you with a broken component. You don't want to just fix that component. You want to also suggest and even almost mandate that they replace all 4 tires at the same time, because otherwise they're going to come back again with another failure. So why does tire size matter? Think about it in tread depth and overall height of the tire. Got a little Letterkenny here today. So if you've got tread depth issues and you got one tire that's maybe a 1/4 inch taller, as that tire rotates, it's going to travel a further distance than the other tires on that vehicle. And so you think about what's happening on all-wheel drive. We've got differentials that are allowing for an indifferent speed. You're going to be consistently all the time forcing those differential components to work. And so if it's a viscous clutch type differential, So if it's a viscous clutch type differential component that's allowing for the front axle to spin at a different speed than the rear axle, that viscous clutch component is always going to be working. It's never going to be matching perfectly in RPM. And so when you're talking about viscous clutch, you've got basically friction components, paper steels that are always going to be working. And there's a wear life to those components. They can only have so much friction between them before they just wear the friction material off. And so keep all that stuff in mind while I'm trying to diagnose four-wheel drive, all-wheel drive failure. You may have a customer that brings a vehicle in where it's really obvious that there's tire size differences. And then other times you may have to get out your tread depth gauge and actually measure it. And so in this example here, they're using a tape measure. This, just like your seamstress kind of tape measure, is just it's a flexible nylon string that has measurements on it, just like a ruler or a yardstick. And you're going to want to check the circumference. Also pay attention to tire inflation. If you have a customer that's been running on a low tire for a long time, that's also going to change the overall circumference of the tire. So overinflated and underinflated tires can also become an issue here. They make other types of tools out there. This one's basically like a sliding yardstick. Okay, some shops will buy stuff like this in order to make sure that the tire sizes are all matching. Quicker way to do it. Four-wheel drive components. So continuing on, we've talked about this slide already once in drive shafts and U-joints. You always want to spend time shaking out components. So customer brings a car in with a drivability issue for all-wheel drive or four-wheel drive. If it's a noise, you want to make sure you start shaking components out. In this example, we're looking at a U-joint that is failing, and you can see the red dust. And so the red dust is rust. And the reason there's rust there is because internally on these U-joint roller bearings, these needle bearings in there, they're disintegrating. The grease is gone, water has gotten in there, and the components are now just shredding themselves. So visual inspections will give you some cues, and along with visual inspections, you want to shake these components out. Servicing four-wheel drive units. This part here is very, very important to follow. It seems almost self-explanatory, but fill plugs and drain plugs can sometimes, well, I should say it like this. Sometimes bolts that hold things internally that protrude through the outside of the case can sometimes trick you, and you might think that it's a drain plug or a fill plug. So always follow manufacturer diagrams for locating the drain plug and the fill plug. In this case here, the top plug is the fill plug and the bottom is the drain plug. I have seen plugs on four-wheel drive cases that can actually be put, they don't have a head on the outside, like an oil drain pan bolt, where they're just like a threaded plug. You have to pay attention to those and not thread them in too far. You can actually drop the plug inside the case if you go too far. So you use like a thread sealant when you put them back on, and that thread sealant is basically what causes the seal to take place, and there's no bottoming out of the plug. So some manufacturers use like a bolt that has a head on it. Some manufacturers use just a straight plug that's just threads with an internal like Allen head or square plug. So pay attention to like the tightness. There are lots of stories out there of people that are over tightening these plugs on these magnesium cases and aluminum cases, and they're cracking the threads and causing leaks. Remember, the drain plug and the fill plug, it's only there to keep the leaks at bay. They're not holding components together that are under load, so don't overdo it. Proper lubrication. All manufacturers state some sort of fluid requirements for their four-wheel drive units. Some manufacturers require 30,000 mile intervals for fluid change. Some require 100,000 miles. A lot of manufacturers today are putting sealed for life four-wheel drive units on cars, which is scary. I have a video on a Ford power transfer unit that is an example of sealed for life. There literally is no drain plug on the four-wheel drive unit itself. The only way to get the fluid out is to siphon it out, because Ford, in their infinite wisdom, decided that there's no need to change the fluid ever. It doesn't make any sense to me. Maybe they're experiencing problems with people putting the wrong fluids in. In this particular case, you can see the video. I don't see any special components in the four-wheel drive unit where it would matter, like screwing up friction modifiers. But I don't know, it happens. So proper fluids are important. You could always look up the proper fluids, procedures, fill capacities, fluid specs, and service information. It's always there. So now let's get into failure four-wheel drive components. So we're talking about a part-time four-wheel drive vehicle here now. This light that's on service four-wheel drive is common on maybe GM trucks. Fords, Chryslers, they all have some sort of indicator on their newer vehicles to acknowledge the lack of four-wheel drive. So your old school four-wheel drive is a little bit different. Everything is mechanical. You've got levers, you've got maybe vacuum modulators of some kind that, everything's just mechanical. There's electric switches maybe that indicate that you actually went into four-wheel drive, but there's no brain looking at these components. There's no computer that is determining the functionality of four-wheel drive. On newer vehicles, when you have a push-button four-wheel drive system, you hit the button for four-wheel drive, you are asking the computer to engage the transfer case and the front diff into four-wheel drive. So if you have a customer complaining of a four-wheel drive issue and they have a light on, you can typically use a scan tool, which is one of the nice parts about this. So your older vehicles, you do not have the ability to use a scan tool. On your newer vehicles, you can use a scan tool. And so what you can actually accomplish with a scan tool is you can utilize bidirectional controlling. And so if I have a customer that has a service four-wheel drive light on and they're complaining that there's no four-wheel drive, what's happening there is the computer is not happy with something. And so it may be engaging four-wheel drive. The transfer case is actually switching in, but maybe there's a switch on the inside that's not giving proper feedback, and so the computer doesn't know if it's actually in four-wheel drive. Or maybe it engages four-wheel drive, the transfer case goes in fine, but the front differential doesn't lock in, or the switch that's supposed to be tripped when it is locked in is not giving proper feedback, in that case, the computer is going to go back into two-wheel drive. It's going to lock you out of four-wheel drive because it's not sure if it is properly engaged. So you can have a transfer case that has a fault, maybe internally, mechanically, and it does slide in, and everything electrically matches up, and it'll stay in four-wheel drive, but you won't have four-wheel drive. So there's a few different scenarios here that we have to consider in these four-wheel drive computer control systems. By using a scan tool, we can bidirectionally control and override the computer's ability to kick out. So if I have a four-wheel drive vehicle that has an issue where I hit it into four-wheel drive and it immediately kicks back into two-wheel drive, it's going to be kind of difficult to diagnose it because it's not letting itself stay in four-wheel drive. And so as I'm trying to spin drive shaft components and as I'm trying to isolate where the power flow stops, if it's not letting me stay in four-wheel drive because it thinks it's smarter than me and it's kicking itself out, then I'm going to have a heck of a time trying to diagnose it. So use a scan tool, go into four-wheel drive or transfer case or powertrain, whatever category you need to on that vehicle, and force that vehicle into four-wheel drive. At that point, you can start shaking the car out, spinning drive shafts, spinning front tires, and trying to isolate where power flow stops. So for example, if I put the vehicle in four-wheel drive and I rotate the front drive shaft, but the front tires don't spin, I know my disconnect is somewhere in the front diff, right? So we can shake these things out. We could also put the vehicle, we could start it up and we could put it in drive and we can run it on a lift or on jack stands with all the tires off the ground, and we can get it underneath it and we can look and see, is the front prop shaft spinning? Yes or no? Is the front tire spinning? Is only one of the front tires spinning? Maybe there's a hub lockout issue. So here's an example of using a Tech 2. This image I think is probably 15 or 20 years old. Maybe it needs to be updated. But we're using a scan tool here to bidirectionally control the transfer case components. Here's an example of Snap-on. Okay, so other manufacturers out there, it's not just, your manufacturer supply scan tools. Your Altel can do this, your Snap-ons can do this. In case you didn't know where to plug in a scan tool. All right, not all scan tools are capable of communicating transfer case faults, but anything that is like bidirectional is going to be able to accomplish that. So maybe your simple code readers aren't going to be able to, but if you have a bidirectional scan tool, you're going to be able to pull up codes and command controls on the four-wheel drive unit. So after checking diagnostic codes, you want to start looking up DTCs, like the descriptions, and also technical service bulletins. All manufacturers have common faults, common things that break. In the video series that I want you to watch, there's quite a few videos. They're all short. They're like 10 minutes long. So there's like maybe 5 or 6 videos, 7 videos. They're all short, but they're all diagnostic tips and tricks and common faults. Like Hyundai, for example, their power takeoff unit is very problematic with stripping splines. Ford's on their cars, their all-wheel drive cars like the Ford Edge and stuff like that, they have a problem with the power takeoff unit baking fluid and causing leaks and burning up bearings. GMs have problems with encoder motors on their part-time four-wheel drives. The encoder motors gears like to strip out. Fords have hubs that like to strip out. I mean, every manufacturer has common issues. And so as you start working on, these vehicles, you become more and more familiar with common faults. And so when customers come in, you're probably going to have a pretty good idea, like, hey, this is a Chevy truck and the service four-wheel drive light is on. It's probably the encoder motor. Or this is a Ford truck and it's got a grinding noise coming out of the front end and no four-wheel drive. It's probably a hub issue. Hyundai, Ford, or whatever. Technical service bulletins are going to advise you on the common issues. And so if you have a customer complaint of four-wheel drive, always, always, always look up technical service bulletins, service advisories if you're at a dealership, and use that as an aid to help you when you're a new tech or when you're working on a vehicle that you have not seen before. Maybe you primarily work on Chevys and now you've got a Ford in the shop. So you're not going to be as used to the Fords, so you're going to want to look up service bulletins and go from there. Electronically, on your electronic four-wheel drive units, there are always computers involved, and you need to study the wire diagrams. So for example, if you have an encoder motor that is not turning, what can cause that? You hit the four-wheel drive button, maybe you get into the scan tool, so you're skipping the four-wheel drive button and you're just going straight to the computer, right? And so you're commanding four-wheel drive and nothing's happening. Well, is it a wiring issue? Is it a fuse? Is it a ground? Is it the encoder motor? You can't just slap a component on it at that point. You need to verify powers and grounds. So get out your wire diagrams. Always verify powers and grounds before you replace any electrical component. Let's say, same example, you push the push button and the encoder motor doesn't spin, but you hook the scan tool up and now it does spin. Where's your fault? Is it the encoder motor or is it on the control side? As a matter of fact, General Motors has a very, very common problem on their select button, push button trucks in the late 90s through like mid 2000s. Every single one of these trucks has the exact same problem. I've replaced this switch so many times, and I've also repaired the switch so many times. Look here, you've got like the mode selector, right? So two-wheel drive, neutral, four-wheel drive, four high. On the board itself, the solder joints crack. You can actually open those switches up and reflow the solder and fix it. I've done it on personal vehicles. Now on customer cars, the switch isn't that expensive. You know, it's $40 if I remember right. I don't know. So by the time you spend the labor to open it up and resolder it and put it back together, you're really not any better for the customer as far as cost goes. Maybe if you had to wait a day for the part, you'd just go ahead and solder it back together and fix it just to get it done sooner. But there's really no cost advantage to doing that for a customer. But it's such a common issue that, and you can diagnose it so quickly because you can hook a scan tool up and you bidirectionally control and skip the switch. So always think about diagnostics on these four-wheel drive units by splitting the system in half. This only works for your computer control systems. On your older manually engaged four-wheel drive units, you can't split the system, but you also don't have electronic parts. You have mechanical components. And so it's not that it's any harder, it's just a different way of diagnostics. Here's a shift motor and electrical components. I have a video on how to replace this encoder motor that I would like you to watch. All manufacturers, this is important here. When replacing these encoder motors, these shift motors, on the four-wheel drive transfer case, make sure you follow manufacturer procedures. All manufacturers have a certain position they want you to put the transfer case in before you install the encoder motor. Now, if the encoder motor is bad, you're not going to be able to shift electrically into neutral, for example, because the encoder motor isn't even working. What you're going to have to do is remove the broken encoder motor and use pliers and physically turn the shift rail into the position they tell you to in service information before installing the new encoder motor. If you screw this part up, you can end up breaking a brand new encoder motor. Or you can end up with an encoder motor that does not select the proper gear, and you end up with a four-wheel drive service light after replacing the encoder motor. In that case, you'll have to take the whole thing back apart again. In best case scenario, you're just wasting time. In worst case scenario, you're breaking the new encoder motor. You're stripping it out because it's binding up as it's trying to force its way into a gear that it can't get into because it's already maxed out on rotation. So your first time doing an encoder motor, follow manufacturer procedures. It's always in print. You can find it. It's there. It might not be as obvious to you, but it'll be in the repair replacement instructions. So I've added some additional diagnostic slides here beyond what the textbook actually has in it. So I want to talk about this one here, GM. I'm picking on GM today. All manufacturers have problems. General Motors has a problem with, the term is typically referred to as pump rub. And if you look at the picture here, this technician is pointing a pen at a hole. That is a pinhole that is exposed in the case due to pump rub. So in this picture here, you can see the inside of the transfer case. It's opened up, and here's the pump, right? So the pump is there to provide lubrication to the shafts, the seal, not the seals, the shafts and the bushings, maybe clutch packs on some of these units. But what happens is the pump, you can see these little fingers on the pump, and there's an anti-rattle clip that the manufacturer puts in place because the case is a little bit bigger than the pump's ears. And over time, what happens is this clip breaks, and the clip falls out into the bottom of the case, which does not hurt anything. The leftover piece just drops to the bottom of the pan. But then there's a gap exposed because the clip is gone. And so what happens is this pump starts to rock back and forth, and it starts to pound a hole into the case. Well, I thought I had another slide. So as it pounds a hole in the case, eventually it wears a hole in the case. Now, this in and of itself is not a catastrophic failure. What happens after the hole is there is fluid starts to leak out. And so if you have a customer that is not paying attention to the puddles that are forming underneath their vehicle, let's face it, a lot of pickup trucks are used on farms and in construction sites, and they're not parking on dry pavement. They're parking on grass or dirt or gravel, and they don't notice the leak. Okay? So what happens is the 2 quarts that is inside of this transfer case eventually leaks out, or enough of it leaks out to where the bearings starve for lubrication, the chain starves for lubrication, and you end up grenading the transfer case. So I'm going to advise you on this. Anytime you have a General Motors product in your shop for an oil change, for maintenance of other things, my kids is outside screaming. The baby probably. So she's in a bad mood today. So anytime you have one of these vehicles in your shop, take a look at the transfer case and do some due diligence for your customer. The vehicles that are affected by this range basically like all the pickup trucks, your S10s, your GMC Jimmys. I've seen it on pretty much all of these GM transfer cases, ranging from like the mid-90s to the late 2000s. There's about a decade worth of these. Now, certain vehicles were more problematic. So like the Duramaxes, the diesel trucks, they all have this problem. They're heavier duty. I don't know what the exact reason is. The clips can break on all these transfer cases. There's different models that GM used, but they're basically the same design with different internal components to be able to withstand higher torque or maybe different gear ratios for low. But they all kind of look the same with the pump on the inside. And they all have that anti-rattle clip, and they can all experience this exact same problem. And so if it's a 1500, 5.3 liter half-ton Chevy truck, it can experience this. If it's a Duramax, it can experience this. So anytime you have a customer's truck in the shop, take a look up in the back side of the transfer case and look for this pinhole. do them a favor because they won't notice necessarily if it starts to leak. It's not going to be a major leak. It's going to be a drip. It might take 6 months. It depends how long they drive. It could take a very long time before it actually pumps out enough fluid to cause a failure. So how do you fix this? Don't JB weld it. There are, excuse me, there are people online that have talked about JB weld repairs. I don't have any personal firsthand experience with the JB weld fix. If it's your personal truck, maybe give it a shot. There's a guy on a forum I read that got like 20,000 miles more out of his transfer case before he had to take it apart, but it wore another hole in it after a little while. So for a customer's car, you're going to have to disassemble the transfer case. You're not going to patch this from the outside. You're not going to sit there and weld it back up because you're not fixing the root cause of the problem. If the clip is gone, it's just going to continue to beat that hole. So if you patch the hole, it's just going to make a new hole. What you need to do is take the back half of the transfer case off, and you can actually repair these without removing the entire transfer case from the vehicle. It's easier, in my opinion, to just go ahead and drop the whole transfer case, put it on a bench, split the case in half, replace the back half case, or you can repair it from the inside and the outside. You can sometimes save these cases if you're good at welding and you want to get in there with the Dremel and grind it back down and make sure that it's not going to leak. But during the repair process, you're going to do something about this clip. You can buy a new clip and install it, and that'll fix the rattle issue for a period of time. I mean, it could last another 150, 200,000 miles with a new clip. They make aftermarket clips that are of better metal design and they don't snap so easily. But then there's also other manufacturers on the market that sell updated pumps. And so the pump itself, you open the pump up, you split it in half, and you can actually replace it with a billet aluminum pump like cover that fits more snugly into this groove. So there's a few options on the market. If you're dealing with like high performance or like a diesel truck and you're fixing this for a customer, you probably want to go with like the best repair possible. So like the pump half, I've actually done that on pump halves before. I've replaced them. Merchant Auto is a company online that sells one of these. I think it was like $100 for an updated pump that was a thicker billet aluminum instead of like this really thin metal. And you don't put a clip back in at all. It just fits really snugly into those case grooves, and it eliminates the pump rub issue entirely. So enough on that. Let's move on. Stretch chains. In this picture here, you can see a stretched chain. Notice how the chain and the gear, the sprocket, are not making contact at the top half. As chains wear out due to improper lubrication, not having enough fluid, enough oil, heat will start to build up in these components and chains will start to stretch. Now, chains can stretch over time just with mileage. They can stretch because of abuse. If you have a customer that drives in four-wheel drive a lot, remember this chain is only utilized during four-wheel drive application. This is how the front prop shaft gets its power. So if you have a customer that uses four-wheel drive a lot, if they're on a farm and they're always towing around some sort of hay wagon or something, they're probably just going to stretch this chain out because, I mean, it's just getting used all the time. If you have a customer that's running their transfer case low on oil, excessive heat can build up and cause the chain to stretch. Long story short, in a worst case scenario, you can actually lose four-wheel drive. If that chain gets so bad, so stretched, it'll actually skip and do a burnout on the sprocket. It's very loud when this happens. So the customer's probably going to complain of a horrible grinding sound only when they engage in four-wheel drive. If it's stretched bad enough, it can also rub into the case. There's not that much clearance between the chain and the case. So if you pull one of these apart, pay attention to the case itself and see if the case has a whole bunch of wear marks in it. It is possible that you can wear it out so bad that the chain, just snaps. And if the chain snaps, you can end up with a case that is broken in the end. The textbook shows you a diagram of like a hub. This is a four-wheel drive hub on a Ford, how all the components kind of spline together. Any one of those spline components can strip out. Towing a four-wheel drive, it's always advised to flat tow on like a rollback. So figure A is always advisable. All-wheel drive is really what this should say, not four-wheel drive. Four-wheel drive vehicles that are part-time, or you can disengage four-wheel drive, you can tow it like figure B has. You can raise the rear tires without dropping the drive shaft. The front axle is in neutral, right? So you should be able to spin this vehicle because it's not going to be rotating the prop shaft. The drive shaft in the front is not going to be rotating if you're in two-wheel drive because it's disengaged in the front differential. So that figure B is actually okay for a part-time four-wheel drive vehicle. I guess, hold on, they got dolly wheels on here. Okay, so they're giving you, I overlooked the fact that there's dolly wheels on there. Figure B, if you didn't have these dolly wheels, is okay. You can actually roll the front tires on a part-time four-wheel drive on the pavement. A and B, I guess, are talking about getting the tires stationary on some sort of rolling device. They're not letting them roll. All-wheel drive vehicles, let's move on to this. All-wheel drive vehicles that are all-time all-wheel drive absolutely cannot ever be flat, like towed with their tires on the ground. The only time you can get away with that is if you can remove a drive shaft. And even then, it's not advisable. So those of you that tow vehicles, if you got a car dolly or something like that for you're going to go fetch a customer's car, or maybe you have a tow truck in-house for your repair shop, keep that in mind. And I think this is probably, I'm not in the towing industry, but I think this is probably why you see so many rollbacks, like figure A here, because it just eliminates the issue. And a lot of those like older style tow trucks that just had the wheel lift, you don't see so many of those anymore, probably because of all the issues that can come up with towing those vehicles. So let's move on. Identifying your four-wheel drive transfer case unit. All four-wheel drive transfer case units should have an identifier on them of some kind. It's usually a round tag, as illustrated in this picture here. If you look at it closely, the top side here says model. This is a 242D. It's a new process. New process is the manufacturer of this transfer case. The model of it is 242. So if you're ordering parts for a four-wheel drive unit, if you need to buy a chain or a pump or gears, you're going to rebuild it. Always pay attention to that tag. Manufacturers, let's say you got a Ford F-250 and you have two engine options, you might have two transfer case options. So simply going off of Ford F-250, that might not be enough. Chevy 2500, that might not be enough. The VIN number should also lead you to the correct parts. The rest of this here is just the teardown procedures. Teardown procedures can always be found in service information. So always consult service information for teardown procedures. You guys have all these pictures in your text. There is one part here that I wanted to talk about if it's in here, and that is the clip. And I don't think I see it. There's a, I thought the book had it. That picture's not in there. A lot of these transfer cases have a clip that's hidden in the output shaft portion. So I'm going to end on this. I'm trying to find a picture here that'll work. We'll go here. So before you can slide these case halves apart, a lot of these four-wheel drive units have a clip that's hidden. It's like an internal C-clip, and it'll be on the output shaft side of the transfer case. And there's usually like a rubber plug, and it's a rectangle in shape, and you have to pull that rubber plug out in order to expose the clip on the inside. And you'll use some sort of snap ring pliers to expand that clip. And that clip rides on a bearing on the inside. So you'll have like a ball bearing and the outer portion of that bearing is going to have a groove in it, and the clip locks around that bearing and keeps that bearing from sliding around in the case, but it also prevents you from sliding the case half off of the bearing. So I've seen a lot of students have issues with this, not being able to split the case apart. They can get it maybe like an inch open, and then after that, it doesn't want to move anymore. Don't ever forget that clip. If you start to force it at that point, you're going to break something. And you can't actually break, you can break the case, because if you put too much force on it, you can snap the ears off inside that case, and then you have to replace that case half. So anyway, this chapter is fairly short. Make sure you read through it. Get a hold of me if you have any questions. Watch the videos that I put up on YouTube. The videos are pretty good at the diagnostics, how to like step-by-step go through and troubleshoot. They're short. There's a lot of them, but they're short, and they get to the point pretty quick, and they're very, very beneficial. So make sure you read through those. All righty. Get a hold of me with questions. See you later.